Hello everyone, welcome to the session. So in this particular video, we will try to discuss about the 2D array, okay? So until so far, we have seen that, okay, there is something called as one-dimensional array, and we did a lot of discussion about that. Then we have also seen that if suppose we want to access the address of any particular element as array is of the form of a contiguous memory allocation, we can access that using some formula that we have defined. Now, afterwards, we have seen that whenever we are having a 2D array, it means that we are having a specified rows and columns in that, right? And the way to store any 2D array in the memory is either in a row major form or in a column major form. Now, in today's discussion, we will talk about that, okay, if the array is stored in a row major form, means if row-wise I am storing the elements inside the memory, because in memory there is nothing as such concept of 2D. Only in the form of 1D only things will get stored, although we are having a 2D array. So at that point of time, how I will be able to access any of the memory location inside the array data elements, that is what we need to see in this particular session. I hope that the agenda is pretty much clear to everyone. So let's get started. So for example, discussion is all about 2D array. Now in this particular case, suppose I am having the element like 10, 20, 30, 40, 50. Then I am having 60, 70, 80, 90 and 100. Then we are having 110, 120, 130, 140 and 150. Then suppose we are having 160, 170, 180, 190 and 200. So here these are the kind of values that we have, right? Okay. Now what we can do? So here by default, row indexes will start from 0. It will be 0, 1, 2 and 3. Again this will be 0, 1, 2, 3 and 4. These are the columns and these are the rows that we have, right? These things we have already covered up. Now suppose I want to see the memory location for this 200. First of all, how can I access this element 200? Suppose this is an array defined in the array. So we can say that array of what is the row number that we have, which is 3, and what is the column number that we have, which is 4. With the help of which, by specifying simply the row number and the column number, we can access any of the element present inside the 2D array. That's quite simple, right? Now, we all know that the very first address which is here in our 2D array is array of 0, 0 is the very first address, is something which we called as a base address. And suppose we are storing this particular data in the form of a row major form. By saying this, it simply means that I am storing my data like 10, 20, 30, 40, 50, followed by 60, 70, 80, 90 and 100, followed by 110, 120, 130, 140, 150, followed by 160, 170, 180, 190 and 200. Fine. So this is the way with the help of which we are storing the data elements that we have inside our 2D array. Okay, that's pretty much fine. Now suppose the base address which is given to you is suppose 1000. And you want to access this 200 element location. You want to access this. So how we can access this? So obviously we need to first of all skip the above 3 rows, right? We need to skip these 3 rows completely and we need to reach to the last row, and then we need to see that how many number of elements we need to skip to reach to this particular location. So basically what you are trying to say is that you want to find out the location of the array which is having index 3 and 4 what you are saying? First of all, we will start with the base address, which is 1000, plus now you know what is the row, that particular row where you want to go, 3, minus what is the lower bound of the row, 0, multiplied with, so it means that 3 rows you need to skip. In those 3 rows, how many number of elements are there? The number of elements are equal to the number of columns that you have, which is equals to 5, right? Here if you will see, in our case, the number of rows are 4 and the number of columns are 5, because the matrix that I have generated here, or the 2D area that I have taken here, is 4 cross 5. So it means that we need to basically multiply it with 5. It means that we are skipping 15 elements. 3 minus 0 is 3 into 5 is 15. And that's true. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. That's completely fine. But after that, we are also skipping these 4 elements. How this number 4 will come? Plus, you need to see which particular column you want to reach, which is 4, minus what is the lower bound of the column? It is 0, because lower bound is the index number. Lower index is 0 by default. Now you are able to observe here that these many elements you want to simply skip. So it will be 15 plus 4, which is 19, and here if you will see 1, 4, so 5, 10, 15 and plus 4, 19. That's true. Now we need to multiply completely it with the size of each element. What is the size of each element? Suppose I am saying that the size of each element is 2 bytes. So we will multiply it with 2. So what we are getting here? We are getting 1000 plus 15 plus 4. These many elements I want to skip, and each element size is 2 bytes. So it will be 1000 plus 19 into 2 is 38. It means the address is having 1038 memory location. So how basically we will be able to reach that conclusion? It's just that we should know what is the base address that we have. We should know what is the ith position I want to reach. We should know what is the lower bound of my row that I have. We should know what is the jth position I want to reach. We should know how many number of columns that we have. So this bracket simply shows how many number of elements we need to skip. That's the simple thing it is showing, that how many number of elements need to skip. That's the simple thing that we want to see here. Okay, so in general, if suppose someone is asking to you that if suppose you want to find out the location of any array ij, so how you will do that? Simply you will say that I will say what is base address. So whatever be the base address that is given to me, plus if I will try to just simply put the values on the basis of the above equation, I minus what is the lower bound of a row. So lower bound by default will be equal to 0, because that's the by default index in an array, multiplied with the number of columns which are given to me, plus j minus lower bound of the column which is given to me, and as a complete multiplication of this bracket with the size of each element. Size of each element, right? That's the simple thing which you have to see here. Okay, I hope that this is making sense to everyone. But this formula is applicable only when you are dealing with a row major form. Only when you are dealing with a row major form. If suppose you are dealing with a column major form, at that point of time, what will happen? Just wherever you are putting the value as I, you need to put j. Wherever you are picking up the lower bound of row, you need to pick up the lower bound of column. Wherever you are multiplying with the number of columns, you need to multiply with the number of rows, right? Because column, what is column major? Means I am, instead of going towards from left to right, I am now going to store the data from the top to down, right? Top to bottom. So in the column measure form, my formula will look like, in column measure form, my formula will simply look like, that is, that what is the location of R of ij is simply which is equals to what is the base address plus the value of, j minus lower bound of column multiplied with the number of rows that we have plus the value of I minus the lower bound of rows that we have, and complete multiplication with the size of each element. That's the simple way to find out the location of any of the element, either in row measure form or in the column measure form. And that's all about the addressing part in a 2D array. So that's quite important, and in maximum number of times you can face any interview based question where they are giving you this kind of questions as a MCQ and will ask you these sort of questions. Moreover, these are the fundamentals, and I believe that these fundamentals should be clear in order to get a clear-cut idea about the advanced concepts of any of the things, right? So with this, I think we are good to start and deal with the applications of array that we have, that is searching and the sorting operations. There are few operations which are an application of divide and conquer approach that maybe we will discuss when we will start our algorithms module of divide and conquer. But apart from that, whatsoever applications we have in an array, I want to discuss those things, and then what are the kind of questions which can be asked to you in an interview as a coding perspective. That things also we will discuss in our videos. So I hope that you all are excited with me to discuss all those aspects as well. With this, happy learning to all. Bye bye everyone. See you soon in my next upcoming session.